Hi, my name is Julian Hunt. I'm going to present a paper submitted to ENCIT 2020 entitled Increasing Hydropower Generation in Antas River with Seasonal Pumped Hydro Storage, authored by myself, Natalia Weber, Lara Vieira, and Paulo Schneider from the postgraduate program in Mechanical Engineering from the Federal University of Rio Grande do Sul. I'm a visiting professor at PROMEC, and I'm also a postdoctoral researcher in the energy program at IASA, International Institute for Applied Systems Analysis in Austria. As a brief summary of the presentation, I'm going to introduce seasonal pump storage plants. I'm going to talk about a proposed plant in the Antas River. I'm going to give details of the dams, existing dams in the Antas River. I'm going to talk about the environmental and social impacts of the proposed São Tomé Dam and also go through the potential for pump storage in the basin. So pump storage hydropower plants, they consist, they are different to conventional power plants. Conventional power plants, they're built in the river, and usually storage reservoir plants are built on the head of the river to regulate the flow and optimize hydropower generation. Pump storage plants, they are built parallel to the river. They have storage capacity, so they work similarly to these storage reservoir, conventional storage reservoir dams, but they are built parallel to the river, so you have to pump water from the main river to this reservoir, seasonal pump storage reservoir, when you have excess water in the river and you want to reduce the spillage of water downstream the seasonal pump storage plant. Then when the river flows smaller and you want to increase hydropower generation, you release the water and then increase the electricity generation in the dams downstream. So the seasonal pump storage plant in Antas River proposed here has a 8 kilometers tunnel, average generation height of 340 meters, a maximum reservoir altitude of 875 meters, which is very interesting because you pump the water higher topography, you store a lot more. Apart from storing energy, you store a lot more. Apart of storing water, you store a lot more energy with the water that you have. This powerhouse doesn't need excavation because it's built already below the river level. Usually, you need to excavate these powerhouses to avoid cavitation. So this is another benefit. The lower reservoir of this power plant is the Passo do Meio dam, small hydropower plant. And as you can see, the Antas River doesn't have any storage reservoirs. It's only run of the river. So whenever it rains a lot, you have a lot of spillage, you waste a lot of hydropower potential, and when it's dry, you don't generate almost any hydropower generation because you don't store. So building this seasonal pump storage plant parallel to the river will give storage capacity to the basin. So the catchment area is this in blue. This is catchment area for the seasonal pump storage plant. This is the catchment area of the rest of the Antas Basin. It's a reasonable size of catchment area, which can then be pumped and stored in this reservoir in parallel. These are the small hydropower plants built already. This is the large power plant built. This is also a small hydropower plant in the Antas River. So in the Antas River, you have plants with 30 megawatts, 29 megawatts, up to 130 megawatts. Some are operating, some are planned, and none of them have storage capacity. I'm gonna leave all the information here for you to look in detail in your house. So this is the topography around the São Tomé seasonal pump storage plant, and this is at a minimal altitude of 740 meters, and I had to create this model to estimates the volume that you can store. I used the topography from the location, and I varied the altitude of the reservoir, estimate the volume storage, and the maximum altitude proposed for this dam is 174 meters. Can store a lot of water. So there are three proposed dam heights. One, the smallest with 140 meters, the intermediate with 190 meters, and the highest dam with 215. The 215 meters dam can store 2.7 kilometers cubic of water, which is the size of Barra Grande Dam, in the similar size to the Barra Grande Dam in the Pelotas River in the Uruguay Basin. And the other ones have a smaller storage capacity. But all of them, they have a very small flooded area because the reservoir has a small area, but it stores a lot of water because of the variation in altitude. So the variation in altitude is something like 120 meters, which is very large for a storage reservoir. So looking at the variation in height compared with the storage volume, you have that the dead altitude, the smallest, the minimum altitude for the plant is proposed to be something like 740 meters, and the maximum 875, which is more than 120. But of course, there are different arrangements that can be done. As you can see, this curve, it starts small, but as you go up, it's the volume storage capacity of the reservoir increases exponentially. So yeah, you can store a lot of water in a small area because the altitude increases a lot. So altitude increases the volume. Looking at the benefits of the construction of the São Tomé season pump storage plants in the Antas Basin, you have that for the operating plants, you have a total installed capacity of almost 500 megawatts already. The planned dams, not installed yet, is 165, and the proposed capacity for São Tomé plant is 1 gigawatt. So this 1 gigawatt is for seasonal storage. So when it rains a lot and you will lose all that water, what you do, you use this capacity to pump as much water as you can. But of course, if you don't have rain, you don't have water to store in your reservoir, it can be used to store energy from solar power, solar generation, from wind generation, from Osório, or from other parts of the state of Rio Grande do Sul. It can be used to generate peak generation during times of peak demand. So this capacity can be used for several reasons. But the main reason what we're exploring here today is to store energy seasonally to increase the storage capacity of the basin. And it turns out we created a methodology to estimate the increase in hydropower generation with reduction of spillage, and it turns out that the average generation of the existing plants would increase 150 megawatts, and the proposed plans in the future, it will increase 260 megawatts. So you invest 1 gigawatt in this São Tomé plant for storage, and then you gain this 400 megawatts in the cascade that you increasing the capacity factor of the existing plant. So it's a very interesting case study to be looked at, and yeah, the main results. Looking at the impact of this reservoir, there is no environmental protected areas. There is no limitation. There's no parks, municipal, state, or federal parks around the area. And the only possible reason that could I mean, there are a lot of other reasons. You have to buy the land, you have to permit, but there is no exclusion zones. No? There is a community called Cazuza Ferreira, I'm sorry. And if you fill up the reservoir to this maximum altitude, so if you use the highest dam proposed, you would the upper reservoir would reach something like 1.5 kilometers from this community. It's not going to flood the community. You might have compromised some roads, access roads around the area. That's also the main concern for this project. Looking at the potential for seasonal pump storage and daily and weekly seasonal pump storage projects in and around the Antas Basin, you have these green dots. The green circles with a dot in the middle. They show the projects which are cheapest, so you can store a lot of energy with one seasonal pump storage reservoir cheaply. So the idea of these projects is that the dam is large, the flooded area is larger. The idea is to store as much water as possible with the least cost. So I created a computational model in Python. I have the topography of the region. I created a model to estimate the cost of projects, and this is the result. Please let me know if you are interested in these results. I can send it to you. It's open access. I already published the paper, and it's interesting. I also have the data in Google Maps. So the idea, if I were in Google Maps, I click in each project, it would show the length of the tunnel, the size of the dam, the flooded area, the cost of pumping, something like 30 different details of the project. And these are the projects. The circles without the dot are the daily and weekly pump storage plants. So this type of plant is a small reservoir, small dams. The idea is to generate electricity for peak hours, is to store electricity when you have a lot of wind generation. As you can see, Osorio is somewhere around here, so there is some potential close to Osorio in the Serra Gaúcha. And yeah, so the cost varies from 1.8 to 2.1. It's not a huge variation. These seasonal pump storage, they vary more because it's very difficult to find very good locations to get these reservoirs. But small reservoirs, it's not so difficult. So the availability is much larger. So this is just the result from the model. This is the topography, goes through every dot, looking for estimating the cost, the size, the costs. So these straight lines connect the center of the dam with the river where the water is taken for storage, for daily and seasonal storage. Also, the reservoirs are smaller. And then I take all these projects and create a table and select the cheapest one. So in conclusion, concluding this presentation, the seasonal pump storage is very interesting for the Antas River because it will regulate the flow of the river. The Antas River at the moment has no large storage dams, so then it will increase the regulation, increase the storage capacity, will reduce the spillage, and increase the capacity factor of the existing and planned dams in the basin. These plants can also be used for generating electricity during peak times because they are conventional storage plants. They can also be used to store energy from intermittent sources, which is interesting for the state of Rio Grande do Sul because they have a lot of wind power potential that can be explored in the future. Another issue which I didn't mention so much is that the seasonal pump storage plant will store water, and then they can guarantee the flow of water in the hydropower plants to generate during peak times. So the idea is that as the water is stored in the head of the river, you will slowly release, and this water can be used for peak generation. So all that capacity of the river will if you have a drought, if you have a low flow of the river, you won't be able to generate during peak times because you don't have water. So having water, you can generate in the whole basin peak generation, which is very valuable. It's more expensive the electricity that you generate. And another final comment is it stores water. For example, in the beginning of 2020, the basin had a lot of issues with a drought, and water doesn't is not only used for hydropower, but it's also used for irrigation, for water supply, for environmental reasons, and yeah, so that's another benefit of the system. Thank you so much for your attention, and very interesting to talk to you. So please ask your questions. Thank you.